All right, so here's a wrap up of these two graphs. Again, I'm hoping we're going to do this in class, so maybe we've already done this. All right, so your original position versus time graph was the one that looks like this. And it was a parabola, okay? And write an equation based on the trend line box. So you had this equation given because this is a quadratic, okay? All right, now we want to go through and fill in the actual variable names and numbers. Okay, so y is actually going to be position. Okay, we'll call that final position. Okay, and then the a, let me see if I can go back and get mine. I think mine was like 104 or something. Hang on a second, I'm opening mine back up. Picking quadratic. Let me see what mine was called. Okay, so my numbers were 100.3. And I'm going to leave a space for some units here. Okay, x squared is going to be time squared because that's my x variable. Okay, plus my b was about 5.0. I'm going to leave some units there. X is t. Okay, plus my c was negative 0.01. And then I'll leave a space for some units right here. Okay, all right. So this is the equation that I'm getting from the parabola. All right, and then let's think about what the units would be. So this is a little bit trickier than just finding the units of a slope because we need the units to work out. And in science and engineering and physics, looking at the units is often super helpful, okay? So I know position has to be in meters, right? So I know everything here is going to have to be in meters, right? Because I can only add apples, 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 and get apples, right? I can't add apples, oranges, and bananas and get apples, all right? So everything's going to have to be in meters. So this one's easy because this one's a constant, so that's going to be meters, okay? Here, in this term here, 5 something units times time has to come out to be meters, okay? So time is in seconds, so then I can see this unit's going to have to be meters per second, see, because then those seconds are going to cancel. And same thing over here, I'm going to have meters per second squared to cancel out with this time squared. All right, so this is what my whole graph is going to look like for this one. Okay, so x final equals 100.3 meters per second squared times time squared plus 5 meters per second t. Whoops, because I could just put minus 0.01 meters. Right? Which this is very close to 0, so that should give you a little hint as to what that's going to be. Okay? Now, when I'm looking at my linearized graph, I had time squared down here, and then that comes out to be a line, okay? This is the same relationship, right? This graph, both of these graphs came from the same data from the same puck. All right, so nothing is really different. It's like we're just saying it in a different way, right? So maybe with this parabola, we're saying, you know, hello in English. And in this purple linear graph, we're saying like hello in Spanish. We say hola or bonjour or whatever, okay? It's still the same message, but it's just a different way to say it, all right? So in this case, this is a line. So this one, we're going to start with a y equals mx plus b, okay? Use a different color, how about red? All right, so my y variable here again is going to be x, we'll say final, okay? And then my slope on this one, I think mine was like 104. Hold on, let me change my graph back. Time squared, done. Yeah, I have to make it linear. Man, that looks really good though. We have to do this in class. Okay, all right, so here goes my linear graph. So my a value in my linear graph was 104.2 something. And now my x variable is now t squared, okay, right? Because see, that's now on my x-axis, okay? Plus my y-intercept was 1.05 somethings, okay? All right, so again, right, I still have to have this be meters, meters, meters. Everything still has to be meters because it's an x equals, all right? So that means this is going to be meters, all right, and this is going to be meters per second squared. Okay, all right, so this, basically what we're saying is this is the same equation, okay? This one, we just kind of missed this middle term, right? But in essence, this here is the same equation, okay? the numbers aren't perfect, right? Because there's a lot of like math, rounding, and manipulation. But you see this number here is practically this number here, okay? That's the same number. This and this, yeah, practically the same number. That's a little bit high. I don't know why that's a little bit high, right? So what happens is when this mathematically manipulates and starts changing stuff, like it just, the uncertainty propagates through, right? It makes it worse and worse and worse, okay? But this, in effect, should be the same equation, right? Because this is telling the same story. Oops. Same equation, same story, right? The relationship is the same. X is proportional to t squared, okay? Whether we see it like this, and we see the squared in the shape, okay, or whether we see it here, we see the squared in the variable, okay? Those should be, in effect, the same equation, right? These numbers, you know, given the techniques we have, are very close, okay? And then just don't worry about this middle number for now, all right?